This is Dr. S. Mohan Lakshmi, Professor and Head, Department of ECE from Rohini College of Engineering and Technology, Kanyakumari District. And the topic for this video lecture is 8051 Microcontroller Addressing Modes. Here, on completion of this video lecture, the students will be able to explain the different types of addressing modes. They will be able to contrast and compare the addressing modes. They will be able to write the assembly language programming using these addressing modes. And we have 5 types of addressing modes in 8051, which is immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and indexed addressing mode. We'll see one by one. And of course, we know that addressing mode is defined as the way we fetch an operand. It can reside in a register, it can reside in a memory location, or it can be mentioned indirectly, or it can be mentioned directly. So we'll see one by one. So the first one is immediate addressing mode. So here we access the data which is specified directly in the instruction, or we can say that it is specified by its value. So in the first instruction we can see that move a comma hash 0, which means that 0 is moved into the accumulator. So similarly, I have given certain examples, which is moving the value into the particular registers. Either it's an 8-bit register or a 16-bit register. And a very important thing to be noted over here is the indication of a hash sign. So whenever we indicate with a hash sign, it means that we are moving, or we are having or representing an immediate value. Coming to the next addressing mode, which is a register addressing mode. Here we specify the operand, either the source or the destination, in one of the CPU register. So I have listed certain examples where you could see that the source or the destination represents the registers. So it can be an accumulator, it can be your registers of a register bank, it can be DPH, DPL, which is from the data pointer. And the other important note is that we cannot move data between registers in a register bank. So which means that, for example, I say here move R4, R7 is invalid, or it is incorrect. Coming to the next addressing mode, it is the direct addressing mode. So we specify the data by an 8-bit address. So normally this addressing mode is used to specify or accessing the data from the internal RAM location, say usually from 30 to 7FH. And here I've listed out certain examples. Move a comma 70, which means that I'm copying the contents of 70, that is the RAM location content 70, to the accumulator. Similarly, I have given example move R0, 40, 56, A. And the other important thing to be noted over here is the stack operations uses only the direct addressing mode. For example, say I want to push the content of accumulator into the stack. So I cannot write push A, it is invalid. So I need to write it as push E0, which is nothing but E0 is the address of the accumulator. Suppose I want to push B, then I should write push 0 F0. So whatever be the case, the stack operation has to be performed only with the direct addressing mode, either the push or the pop operation. Coming to the next addressing mode, which is the register indirect addressing mode. Here we can use the registers R0 and R1 as pointers to specify the data. And the important thing to be noted over here is R2 to R7 cannot be used as pointer. So for example, I have given move a comma at R0, which means that whatever content I have in the location pointed by R0 will be moved to the accumulator. Say R0 is having a value 40, and whatever content I have it in the location 40 will be moved to the accumulator. And here the advantage is you can access the data dynamically rather static in the direct addressing mode where we can use only the static addresses, but here it can be dynamic, which means that suppose I want to move a lump of data or a block of data from location 50 to 60h for say example. So what I can do, I can initialize that 50 or the starting location of the block in a register or not, and I can keep on incrementing that such that I move the dynamic data rather static. And the limitation is, of course, we know that we are using only R0 and R1, so which are 8-bit wide, and this can be accessed only from the internal RAM. Obviously it is have 8-bit addresses, so you can access only from the internal RAM. So there can be a scratch pad or it can be from the SFRs, special function registers. And coming to the last addressing mode, which is the indexed addressing mode. So you can access the data from the ROM space of 8051 or external RAM. In all the previous cases, we could access the data only from the internal RAM. No external memory is involved. So in this case, you can make use of this addressing mode to access the external RAM. So normally when we go for accessing the ROM space, so this is either the source or the destination address will be the sum of the base address and the accumulator, and the base address could be normally a DPTR, data pointer, or a program counter. Say for example, I've given move DPTR with 4000H, which means that I'm moving a content 4000 to DPTR, as well as I'm moving a content 5 to the accumulator. Suppose I want to move the content of 4005. Okay, so what I can do it, I can write a plus dptr at a plus dptr, which means that at 4005 whatever content I have it, I'm moving it to the accumulator. The C in the instruction represent it is a ROM space, it is for the coding. And similarly, the next example I've given is move xa comma at dptr, which means that I'm accessing the external RAM where x denotes external RAM, and whatever content it is pointed by the DPTR will be moved to the accumulator. So these are the possible assessment questions on addressing modes, like what will be the instruction move a comma 40, or in accessing the stack what addressing mode is used, which registers are used for register indirect addressing mode, and even some program can be asked using the addressing mode. Thank you.